Hey everybody, Adam Savage in my cave with a toy. This right here. This is it's a flywheel car like we all had as children. I love these things, and I have this desire to make one really, really big. This started as an idea for back when Jamie and I were touring a science show around the world between 2012 and 2016. And I wanted, I sought a certain kind of gag. Specifically, I wanted to build one of these so heavy that like we could bring it up on stage and start it and like someone couldn't stop it. There are problems with doing something like that on stage. There are, cascading sets of potential issues with such a thing. But I couldn't get out of my head this idea of a really heavy flywheel driven car. And so let's see here. I took a careful look at this guy. And I looked at the gear train, and I noted that there were 4 gears in the gear train, 1, 2, 3, 4, and a flywheel, and that they were directly driving one set of wheels. Let's see here. The wheels as they are, yes. The first gear in the train is 36 teeth. The second is 12. The third is 46 teeth. And the fourth is 8 teeth. That's this last pinion gear here that drives the flywheel. Now, I went online and I was able to find wheels 1 and 3, 36 and 46 teeth respectively. But I was unable to locate a 12 and 8 tooth gear of the same pitch. These are diametral pitch 12 with a 14.5 degree pressure angle. Just briefly about what some of that kind of means. And I'm a good person to explain it because I only kind of understand it. So I'm gonna give you my somewhat understanding of gear teeth and their geometry. So understand that gears are basically individual radial levers doing their work on each other. If you want the maximal transfer of energy, you want gear teeth that are always engaged. That means that there is always 2 surfaces touching on those gear teeth. If they're not touching, you end up with gears that rattle like that, and those are fine. There are lots of gears in the world set up with tolerances that they can actually move a little bit. But the best transfer of energy occurs when the geometry of each gear is such that the teeth interlink in this really, hold on, I gotta see there. There we go. So you can go read papers about these sliding geometries and how where the pressure angles are and all of that stuff. You don't really need to know all of that. I've got 2 gears here that are diametral pitch 12. That's a known quantity with a 14.5 degree pressure angle. And when I know those 2 things, I can buy a set of gear cutters that are pre-shaped to create the proper geometry of the teeth. And a full set of gear cutters looks like this. Now, to the immediate glance, this looks like these are 8 of the same thing. But in fact, actually, there's a really fascinating reason there are 8 of these, because you use a different one depending on how many teeth you have radially around your thing. So what I'm about to do is I'm about to go online. Actually, I think I even have... I should find it in here. It is in here. I know it's in here. I could go online and look up a gear calculator, I'm sure, but I think I'm going to go through the exercise right now of trying to find the information I need here. And the information is you take a DP12 gear with a 14.5 degree pressure angle and you say, I want 8 teeth. And what it will tell you is What is the outer diameter of that piece of metal you've got to turn, and how deep do you cut those teeth? Once I have those numbers for both the 8 and 12 tooth gears, then I am going to break out my dividing head rotary table, and I'm going to cut those teeth with the proper gear cutting. I've never done this before. This is like, my first car was a Volvo station wagon. And when you're first learning how to repair a car, you do the first repairs. The first repairs you do are surpassingly simple. You learn how to change your tires. You learn how to tighten opposing bolts on your tires. You learn where to put the jack, right? This is all very basic knowledge. But when you're first learning how to do cars, when someone says bleeding the brakes, like none of those words mean anything to you when you first start working on a car, because you don't know that the brake system's under pressure, that it's hydraulic in nature, and that you want to get air out of it, and the air gathers in certain places, and when you refill it or you replumb it, you need to actually do this process. At the beginning of car repair, all of that is just this mystery. It's all like, yeah, it's engineering speak. But then as you go through, so in my progression with the Volvo, I started out replacing the tires, and then I had a thermostat go bad. That's a very easy repair in a Volvo 245 DL station wagon. So I replaced the thermostat, and my car worked much better. I was only firing on 4 cylinders at one point, 3 cylinders at one point. The car was still run. I was able to figure out which of the spark plugs was bad and replace it. Later on, oh, right. Yeah, my drive shaft. I had a problem with the U-joint in my drive shaft, and I actually pulled the whole drive shaft out of the car, which was much simpler than I thought it was, and I swapped out 2 U-joints. There used to be this place in Berkeley called RPR Discount Volvo Parts. They might still be there. They were like across the street from the Hotsy Totsy on San Pablo. Anyway, they would like lend you tools if you were swapping out your shocks. They would lend you the compression tools for that. It was a terrific place. I did so much car repair on that Volvo. So I guess what I mean to say is, when one is starting out in a discipline, there are all these levels that from the vantage point you are currently at, there are levels that seem impossible. And for the longest time for me as a machinist, the idea of actually cutting gear teeth, even though I sit there and I watch ClickSpring all the time, the idea of cutting gear teeth that actually worked and looking up the charts and making it work just seemed like that was something for smarter people than me. But frankly, yeah, I know. You didn't expect me to come in with a giant sidearm. Frankly, going through the exercise of making the Samaritan in the summer of 2020, it demystified a lot of machining for me. And part of the demystification was realizing how everyone kind of finds their way to the ways in which they solve engineering problems. And, you know, the learning of a new skill for me is always sort of like wrapping my head around different scales of precision and different outcomes based on my knowledge at the time. And so now I feel like I am qualified enough to cut a couple of gears. I actually have enough gear. I have 2 of each of these gears, so I could build 2 of these cars if I wanted to, but I only have 1 set of tires. Aren't these tires gorgeous? And I have a big, beautiful, oh, look at this flywheel, this big chunk of cast iron. I'm really psyched about this. I want to put this on the street, and I want it to go for like a block. So I may not get to build this whole car in this video. We're going to see how I go. It may be that this video is simply me cutting a couple of 8 teeth and 12 teeth gears. We're going to see how we go today. Where does one begin? I'm going to look in the index under gears. Gears. G. Gearing. Gear cutters, formed, number for bevel gears. Involute form. I dog-eared the page. I've been here before. I don't remember being here before. Well, it would seem that with a pitch of 12, on a 14.5-degree pressure angle that the smallest number of teeth I can cut is 10, which is fine. Just slightly reduces the ratio, but that's not that big a deal. And I could, I guess, if I wanted to, cut a bigger gear than 46 teeth for this, but I'm gonna cut the first one out. So here's the list of wheels that I have. Gear number 1 is 36, 2 is 12, 3 is 46, and 4 is 8. What I think I can do here is do both number 2 and 4 at 10. I'm gonna have to look it up. All right, I looked it up. It turns out it's a 1-inch chunk of stock, and I have this big, beautiful piece of bronze that I cut from a propeller shaft on a boat on Mythbusters, many years in the past. It looks like I'm using a number 1 cutter for 10 teeth out of this. I'm going to machine it down to a 1-inch diameter. And I'm actually going to be cutting this the long way. I'm going to be cutting all the gears. I'm going to be cutting 4 10-tooth gears at once. And the way I'll deal with that is I will machine this down. I will machine a through hole. I will then chuck this into my dividing head. I just trammed up my vise and I got to pull it off again. It's fine. It only takes a few minutes. But I'm going to end up using my dividing head and an adjustable tailstock. I had to look up the name of it. It's written on my machine thing over there. Okay. To the lathe. To the lathe, boy wonder. I'm going to pull out the drill chuck and put in a live center. Then I'm going to crack this, bring this out, and I'm going to mill this whole thing down. And this is probably 125. Is that what it is? Exactly 125. Look at that. All right. So I want to touch it off. Beautiful. Look at that. The jewelry. Bronze cut's really pretty, doesn't it? This is, yeah, I took out 30 thou. All right, so I want to take out 220 thou. So let's try 100. Looking good. Air is the reasonable way to remove heat from a machining equation, and it smokes less than the cutting oil.
Bronze cuts hot, I would say. Bronze seems to cut quite hot.
I just love it. What I love is that it was 220 thousandths and I took off 200 thousandths according to the DRO and I ended up with exactly 20 thousandths over 1 inch. And I just like it when the dials all agree with each other. It is a sweet, sweet business. So we're gonna bring this back over here. We're gonna dial this in 20 more thousandths.
Look at that.
So when you cut metal and you end up with the little chips that come out of it like this is called swarf. S-W-A-R-F. And not a great word. And I'm here to tell you that I think that bronze swarf wins as the most beautiful of all swarfs. Look at how pretty. It's like golden treasure. Man, that's a hairstyle right there. I'm gonna clean that up and look, it's almost like you could name it. I love the bronze swarf. And now the bronze shaft here is exactly 1 inch. This is an intellectual exercise. If I'm off a few thou, it's not that big a deal. But let us, great. Okay, so that's, I'm gonna try out my Minotaur. I am 2 thousandths over. 1.0020. Yeah, that's great. I'm pleased. That is good enough for me to start cutting. Yeah, we're gonna. So now I'm gonna rearrange the bed of my mill to cut some gears. It's gonna take a few minutes. I literally trimmed this in yesterday and got it to like really nice precision. Tramming is just the process of making sure that the vise is perpendicular and perfectly square to the mill on all 3 axes. Best practice on a mill is each time you remove the vise or reinstall something new on the table, just use an India stone to make sure you don't have any dents or high spots. Yeah, that'll do it. Couple more 1, 2, 3 blocks. Tinker Toys. It's all Tinker Toys. Oh, I have an idea. I have an idea forming in my little brain. Oh, right. The question is the table level? Wow, it's all there. Let's see. That's close enough that I'm going to let that stand for a minute. So first up, I want to determine that it is in line this way. So I bring it in. answer is likely to be that I'm way off. Oh, not so bad. All right, as I spin this thing, oh, come on. Okay, I'm about 2/1000ths out of round, which means a total of about 4. That's a sheet of paper. I want to get a little bit better, so I'm going to, let's try that. Let's try that. All right. And one and a half. Let's do one more hit here. Still not the same. Okay, I think I need to loosen this a little bit more. All right, 1 thou out. I'm going to call it. We're going to tighten it down. So let's bring this in and we'll take a look. I ran into a little snafu. These gear cutting wheels are meant to go on arbors that hold them, that look like this. This is the arbor for these gear cutting wheels. And I did not check to make sure I had one to fit the whole size of these, and I don't. However, I can utilize one of these. Nice sound. So I took I had 2 of this mid-size, and I took one of the rings and I turned it down, stepped it down so that it fits the gear cutter I have. And I even machined in a little keyway slot. So I'm going to clean this up and clean this up with a file and get it in there. Okay, so the way I've done this is, yeah, see that? So I'm just gonna machine a little bit of steel that wedgie poos in there and then gets captured by the top capture nut like that. And I have cobbled together a gear cutter with the arbors that I have. Right, so that goes like that. Look at that. Yeah, I'm digging it. It's a half hour I didn't expect. All right, it's not pretty, but I've jammed a little bit of material in there and that should hold on to it. So now I registered this and this thing can't move. So I'll put that guy on there. And that should be, yeah, there's my gear cutter. So this is an R8 collet. This will into the mill and then this will be cutting the gears. The gears! All right, so if, let's do a diagram here. Yeah, okay, so 320 thousandths, and if the top edge is in line with this, that means that the center of the gear cut is 160 thou below the top. So I want to move it 160 thou less than 1/2 of an inch. Or I could come up 160 thou. Yes, I could come up 160 thou. 160, zero it, and then come down 1/2 inch. There we go. I'd let the machine do the math for me. Locked. Okay, so now the gear is in the center of the post. Ladies and gentlemen, I think that's it. I think I just cut my first pinion. It rolls. I don't know, it always seems a lot quieter when Chris at ClickSpring is cutting gears. Oh, it doesn't seem like that. I may have been exaggerating. None of these really moved, so I think I can start to undo this stuff. I can pop that. I can undo this. Oh. Come on. Stay on. Oh, come on now. Out. Yeah, I think I definitely need a new #1 cutter. That's a respectable looking pinion if I sizzle myself. Let's cut it into a couple of useful gears and see if we can't. 230. I might be able to depth these 4 wheels together today. It's not the prettiest of gears, but ladies and germs, it's a gear. It feels pretty good. The tiniest bit rough around the edges. I'm insane if I thought I was going to get to depthing this. I'm still not even sure. There's 2. No, there's 1 stack. 1 stack, and then one of these goes through the flywheel. Yeah. I think this is a great place to stop. I know I still have to do some cleanup on that and make those faces. Actually, I'll do that. There it is. It might not look like much, but it's been a long journey to get here. And I'm including much of my life up until now. My first gear. Baby's first gear. Very excited. A respectable looking pinion, give or take. Just wonder if it will give me the smoothness that I want. I can't tell you how happy I am about this. I know those could look better. That's another video. Thank you guys so much for joining me on this specific journey. The shop is so nice and clean. You guys have a good weekend. I'm assuming you're watching this on Friday just because I happen to be filming it on a Friday.